So in a moment, I'll be describing how to build a Python package from scratch. But first, I'm going to talk about me briefly. I like it when I've got a big projector. I can scare people in the front row with a big photo of myself wearing a Viking helmet. So on Twitter and all good social networks everywhere, I am generally known as GD2K for reasons that aren't as interesting as you might guess. My real name, sort of in real life, is Mark Smith, and I'm a developer advocate at Nexmo. Who's heard of Nexmo before, just out of interest? Oh, a small handful. So we sponsored this conference last year. Obviously, that's not doing so well for us. So I stole this slide from a colleague of mine. He's a much better designer than I am. You're going to see that as a common theme throughout the rest of my talk. So Nexmo provide web-based APIs that allow web developers to write code that sends text messages and makes phone calls or can send messages via different instant messaging platforms. If any of that sounds interesting, please come and talk to me afterwards. I can give you free credit to play around with it. And that's enough about me and Nexmo. I'm going to talk about the left pad problem. So in March 2016, a developer removed a library called leftpad from NPM. NPM is the Node.js equivalent of PyPI. It's a big web service containing lots of JavaScript packages. This broke lots and lots of libraries that depended on leftpad. In the month before it was removed from NPM, leftpad had been downloaded 2,486,696 times. So it's a common dependency in that community. It was just one function consisting of 11 lines of code that padded a string to a certain length by adding characters to the start. Now you may wonder why I'm talking about JavaScript right now at the Python conference. At the time, there was a lot of fallout from this situation, which caused chaos in the JavaScript community. Lots of people from outside the JavaScript community considered that this made them look maybe a little bit stupid. Why would anybody publish a library consisting of just 11 lines of code? Why would anybody use it? Now, the fact that it can be removed like this from a public repository is a problem, but I personally think it made the JavaScript community look amazing. And if you oh, I've done it again. If you disagree with me, you can fight me on Twitter. So in my opinion, leftpad was not a problem. Leftpad was a solution to a problem. Because the JavaScript standard library doesn't contain a solution for adding whitespace to the start of a string, the developer of leftpad solved the problem himself, and then he shared the solution with other developers to make their lives easier. Because it's really easy to share code with NPM, lots of people do, with really small libraries, the type of thing we might normally find on Stack Overflow or in a gist. But copy and paste is not how you should share code. I feel, from my own experience, that people are a little afraid of setup.py, the setup script that's used to install, that you have to write to publish and install your package on other people's systems. The docs and best practice have been a bit tricky to put together, but they're getting better all the time, and hopefully this talk will kind of help a little bit. So every time you publish code, you make the Python ecosystem stronger. You make somebody's life easier. Python is not just a language, it's a community, and that community publishes code. So where would we be, for example, if Django, NumPy, Pandas had never been published? We would have to write some sort of solution ourselves, and it almost certainly wouldn't be anywhere near as good. So let's make a package. So the idea of this talk really is that you've written some code that's useful, that you want to publish for other developers. So I think at some point we've all had to write this code, and obviously that's a negative experience for us, having to write that from scratch. It would be much better for us if we could just pip install it and then use somebody else's code. So we're going to extract it into a file, in this case called hello-world.py. That's our module name. We're going to put that file in a source directory, and I will explain why later if you consider that to be controversial. And now we're going to write a setup script. So this is our setup script. This is about the simplest setup script you can write. For the first line, we import setup tools. We import the setup function that we're about to call. So in the past, you would have used distutils, which is distributed with Python. These days, the best practice is to use setup tools, which is a more powerful library and is actually part of pip. So if you're using pip, you already have setup tools, so this isn't really a third-party dependency. Then we call the setup function and we pass it just a bunch of parameters, which I consider to be a relatively negative thing about setup tools and distutils. But we'll get onto that later. There's some stuff towards the end of the talk about some alternatives to this. But this is the common best practice right now. So you'll notice there's two lines here, the top one and the name and the PyModules arguments that seem very similar, and they almost always will be pretty much the same thing. So name is the name of your package as you publish it on PyPI. That's the thing you pip install. The module is a list of Python files that you want to distribute. So in this case, it's just a single file, so we use PyModules rather than listing the packages. And then the last line is just a bit of boilerplate because we've put our code in a source directory. We've got a description there, which isn't hugely useful, and we've got a version. Your version number will usually be around 001 when you first publish. Keep it at 00 for the first few releases, because you're probably going to be iterating quickly while you kind of put the project scaffolding together. And that implies, when you're a 00x version number, it implies that it's unstable. So now we've written a package. We've barely done anything so far, but we already have something we could publish. So in our terminal, if we run the setup script with this bdist wheel command, which is short for build me a wheel binary distribution file, and a wheel file is the standard distribution file for pip at the moment. So anybody who remembers PyPI being called the cheese shop, which is a reference to Monty Python, may realize that wheel is actually a wheel of cheese. It's not a wheel that you get on a car. So we're still continuing this nice Monty Python reference thing into the future of Python packaging. So we get lots of output, and I've removed some of it. The most important line is the one I've highlighted, which shows that our Python file containing the code was actually copied into our lib directory. That's a good sign, generally. And now our directory structure looks like this. So we've got lots of new stuff. So first, it's created an egg info folder, which I'm going to ignore for the rest of this talk, and I think it's ugly and wish it wasn't there. It's created a build folder, and in that build folder, it's created this wheel file that we asked it to. So this works, which is good. We know it builds, but we don't know that the actual wheel file is any use if somebody installs it. So let's install it. So if we run this command in our virtual environment, in the folder that has our setup file, it will install this module into our virtual environment so that we can use it. If you haven't seen this before, it may seem a little bit arcane. The E flag means that we're installing as an editable module. So what it means is the code won't be copied into our virtual environments library folder. Instead, it just adds the code's existing folder to the Python path. So that allows us to import the project from the files that we're actually editing. So each time we make a change to our hello world PY file, we don't have to then reinstall it into our environment. It's just going to pick up the changes the next time we start up Python. And the dot just means install the current package. So it's because we're in the same folder as the setup.py file, it will install that project. So the end result here is that your Hello World library will now be importable into your virtual environment so that you can run it. So let's test that. So we start up the Python REPL, we import our say hello function from the Hello World module, and then we just call it the two different ways that it supports. And that works. It's going to be kind of tedious if we have to do that again and again, but again, we'll get to that in a moment. So in theory, we can upload this to PyPI already. But I feel there's about 3 things that we need to do first. We need to document it, we need to write some tests, and there's a little bit of housekeeping, which I'm going to go through now. So we need a git ignore file, assuming we're using Git. I really recommend this site if you haven't seen it before. If you put Python in that text box and then hit create, it will dump a useful git ignore file essentially into your browser that you can copy and paste into a .gitignore file in your project, containing a whole load of Python artifacts you might find in a Python project. So if you're using PyCharm, it will make sure that those project folders aren't added, any compiled Python files, things like that. Then we need a software license, because otherwise we're not really publishing our code. People can't use it if it doesn't have a license. So I recommend this site for that. So it's got non-legalese descriptions of each of the licenses. And then once you've clicked through a few links, it will take you to the actual license text, which you can then copy and paste into a licensed text file in your project. And we also need to add some metadata to our setup file. So we've written a very basic setup file, but there's some more useful information we can put in there to help people understand both how they can use the library and what the library does. So in this case, we had a classifiers argument. And I don't know if you noticed the F string in the hello world function, but that was only introduced in Python 3.6. It's awesome, by the way. It's a really good reason to upgrade to Python 3.6 if you haven't already. But that does mean that we don't support Python 2 or Python 3.5 even. So here I've got 3 lines that split, say, in order, this is a Python 3 project, and it runs under Python 3.6, and it runs under Python 3.7. And I've chosen the GPL license here. That's not really important, but you can find all these specific text strings in the link that's at the bottom of the slide there, pypi.org/classifiers. And because there's nothing specific to any operating system, I've said this should run on anywhere Python runs. So in terms of documentation, we need to make a big decision up front. We need to decide which markup language we're going to write our documentation in. It's not an irreversible decision. You can use pandoc to switch between the 2 formats if you want to, but it's best to make this the right decision up front, like anything, really. So we can use restructured text, which is the standard within the Python community. It's really powerful. If you need to build a static documentation site, you can use a tool called Sphinx, which is the same tool that's used for building the Python documentation itself. If you prefer Markdown, which is more understandable for people who aren't from the Python community, so if you're working in a multiple language project or something like that, then Markdown may well be a better choice. There's a parallel tool to Sphinx called MakeDocs, which will also build your documentation site. Both those tools are completely compatible with Read the Docs. So if you decide to publish your documentation to Read the Docs, it doesn't matter which of these decisions you make. So I've chosen Markdown just because it's relatively straightforward. And so if we write a README, it should contain a title and a short description of what the module does. It's amazing how many projects don't actually do that. We need an installation section that describes how to install the project. We need a usage section with a summary of how people might well use the library. And in some projects, a README may be all you need. In other projects, you'll need to write more than 1 page of documentation, as I mentioned, and I recommend Sphinx or MakeDocs and publishing to Read the Docs. But once we've written our README, that's kind of useful as a web. We don't just want that on GitHub, for example. We also would like that as part of the official documentation for our package. That essentially makes up the long description of what our package does. And it would be good to publish that to PyPI as well. And in order to do that, we need to have the content of that README inside our setup script. We need to pass that as the long description argument. So what I've done here is add a bit of code at the top of my setup.py file that just opens that Markdown file we were just looking at. It reads it into a string variable, and then it passes that variable in as the long description argument to setup. And something that we couldn't do before, actually on PyPI, was support Markdown. PyPI didn't support Markdown until relatively recently. Now that it does, we need to tell PyPI that it is, in fact, a Markdown file, and that's where this new argument underneath comes, the long description content type. So PyPI currently, as far as I'm aware, supports plain text, restructured text, and Markdown. So now we've got documentation. We should write some tests. I'm going to be quite dogmatic and say use PyTest. It's awesome. But that does mean that we now have a real third-party dependency. So we need to install PyTest, and anybody developing with our library needs to install PyTest. And so we need something like a requirements.txt file. But more recently, I've been using Pipfile and pipenv to manage that, and I like that quite a bit. So I'm going to use that instead as an example. I'll try to compare it with requirements for the people who are still using that. So we need a pip file. And the nice thing about pip files is that you don't have to write them initially. You may have to edit them later, but mostly it can be managed by pipenv. So once you've installed pipenv, which I haven't covered here, we can run essentially the same command as our pip install with the -e dot flag. And that installs our module as an editable module into our project. And then I've added our new dependency. So I said we've got a development dependency of PyTest, and we want to run 3.7 or above. The thing about pipenv is, as well as managing your pip file and its dependencies, it also manages your virtual env. So as part of those commands, it's created a virtual environment for us. But we need to drop into it if we're going to run Python within that virtual environment. And in order to do that, we run pipenv shell. Now, it's created this pip file for us. It's an ini format file. It's got a few sections, but there's not much that I've removed from here, but I've just summarized the important stuff here. So the commands we just ran added this line to packages, saying we want the current package installed, and we want it to be installed as an editable package. So I think that makes sense. I've no idea what that magic string at the start of the line is, and I can't find any documentation for it. If anybody knows, please come and talk to me afterwards. And then in our development packages, we've said we want to install PyTest, and the version number we specified is there. This is quite useful, but it's not hugely important. The important thing is, as well as the pip file, when it installed those modules, it created a lock file to go with it. This is a JSON file that pipenv manages for you. So when it went and asked for PyTest 3.7, what it got from PyPI was 3.7.2, the latest compatible version, and it installed that. And then it recorded away in our lock file the exact version of all these dependencies that it installed. The idea here is that you commit this lock file to your Git repo or other version control system, and then anytime anybody runs pipenv install on their own machine, they get the exact same versions as you do. And if there's a new version of PyTest comes out and you would like to support it, you would like your other developers to be using the same version, then you run pipenv update, which will install the new compatible version of PyTest. You run your tests to make sure everything still works, and then you commit that new lock file to Git. So it's got a nice workflow. This kind of comes from the Ruby community, I think, originally. So we do need to compare setup versus Pipfile. And a setup file is really, I'm about to add some dependencies to our setup file. But the difference between the two is that our setup file is for production dependencies. It's things that our library depends upon. So it's things like Flask, Click, NumPy, Pandas, things, if you can't run this code without having that code available. And our version should be as relaxed as possible, because our library is going to be installed into somebody else's project, and they may have the same dependencies as us at different versions. And if they conflict, then there's going to be a problem that they have to solve in some way. So yeah, and ultimately we should be testing the full range of those dependencies. And again, I'll talk briefly about how we can manage that in a project. A pip file, however, and a requirements file are for development requirements. So they're for things that other developers need to work with your project. So they are things like PyTest, mock, coverage, things you need while developing this code. And the versions, so with the requirements, I'm going to contradict the last line here because I'm talking about requirements.txt. With the requirements file, you should be as specific as possible with your version numbers because you want other developers to be working with the same tools that you're working with. Pip file, because it manages this lock file for you, removes that requirement. So you can be as relaxed as you like with the requirements in the pip file, and they will be locked down when you first install it and create the lock file. So now that we have PyTest, we can write some tests. Anybody who's worked with PyTest before will know that PyTest is very simple for simple tests. It scales up nicely with things like fixtures and PyTest mock. So here we've just called the function in two different ways and made sure the output is what we expect. And then we can run those tests with PyTest, and it just says it ran our two test functions. They passed very quickly. We get a nice green line at the bottom, hopefully. And I'm just briefly going to actually, I should have summarized that bit, but I should pause at this moment. This is good. We have tests now. I've got a couple of new slides which have ruined my flow. So I want to talk about library dependencies, which I didn't cover the last time I did this talk. So these are our production dependencies that I just mentioned. So I decided I was going to change the code slightly so that we had colorful output for Hello World. So I'm using the blessings library, which is a really handy way of putting terminal color codes in our output. And then so I've just imported it, I've initialized it, and then I've used it as output in the string. So I should actually change those tests, but I'm not going to. But now that we have a third-party production dependency, just showing how that works in the setup file, we just add this install requires argument to setup, and it's a list of requirements, and each of those should also contain the versions that we support. So in this case, I've said that tilde equals means compatible with. So it will install 1.7 or above, but it will not, according to semantic versioning, it won't install 2.0, for example. So that's that. So now, just to take a pause to see what our project looks like, and I've removed the egg info stuff. But now we have our license, we've got our pip file, we've got the lock file, we've got the readme, we've got the setup file, we've got our source file, and then I've just stuck our test file in the top level directory. If you've got more than one test file, it would be much better to stick it in a test directory. But really, I'm trying to get us up to a published module as quickly as possible here, but still within, like, being a responsible citizen, actually make sure that we've got tests and documentation. So as well as a wheel, usually we publish a source distribution as well. This is essentially a copy of a clean version of our project that, as we would maybe check out of Git, but published as either a gzip tarball or a zip file. And we can create these by just running our setup script with the sdist command. And you'll notice I get a few warnings here when I run that, which I didn't get before. And it's just telling me that it would like me to have a URL and author or maintainer information. So let's add that to our setup script. So here, I mean, you can see it's not special. I've added the GitHub repo as the URL. If you have a documentation site, you may want to link to that instead. So we can test this. Once we've run that command again to make sure that we have our source distribution, we can test it by just unzipping it, because it is just a zipped file, a gzipped file in this case. And you can see I've listed the contents, and it's got almost everything that we would expect, but we are missing the license file, the pip files, and the test file. So what this means is we need to create a manifest input file, manifest.in, if you've seen it in projects before. And they're a little bit fiddly, and what we really want to tell it is that we want this source file source distribution to contain the same files as our Git repo. And that seems like something that a tool would do very well. Unfortunately, there is a tool that does exactly this. So there's a tool called check manifest that we can install. And when you run it with this middle line, with the create flag, it will just create you a manifest.in file. I meant to put in the input in a second slide here, but I haven't, I'm afraid. And then you add that to your Git repo, but also once you run sdist again, you will see that it now includes the same files as you would get if you checked out the project with Git. You can also use it every so often to validate your existing manifest.in file. So if you would rather tweak those include and exclude lines yourself, then you can just use this to make sure that you're getting the files you would hope in your source distribution. So now that we have a binary distribution and a source distribution, we can actually publish the library. So let's get this thing on PyPI. So we run setup again with both the bdist wheel and the sdist command to just make sure we have the distributions we expect. And then you can see them when we list the contents of the dist directory. And then we install twine. So you used to run the setup file to upload your project. You shouldn't do that for a few reasons. One, security. So that's enough, actually, as a reason. So we run twine with the upload command, and we just point it at the files that we want to upload. And because we want to upload everything that's in the dist directory, we can use the asterisk wildcard. It will then ask us for our username and password, which you create on the PyPI site if you haven't done already, and then it will upload for us. And then if you get to PyPI really quickly, on the home page, your project will be listed as a recently updated project, which is always kind of cool. So you click on that link, and it will take you to your projects page. You will notice that this is actually Hello World GD2K, so I had to change the name of the package to upload it because some idiot has already uploaded a Hello World package to PyPI. So here we have our nicely formatted Markdown documentation. Down the bottom left, where you can't see it because it's cropped off, is a link to our GitHub repo, which was the URL that we just added. And this is really the bare essentials, I would say, for publishing a package on PyPI. We've got some tests, we've got some documentation, we've published the package so people can use it. I recommend getting your package on PyPI at this point rather than trying to perfect it. There's a bunch of other stuff we can do, which I'm going to go through in a minute, but once you've published your package, people can use it, and then you actually have a reason to keep refining and updating it. If you haven't published your package, you haven't actually, you haven't really done anything useful for humanity yet. One of the things we should do that we haven't done so far, we've run it in a virtual env on our own machine under Python 3.6. In this case, we should really test it against all of our supported versions of Python. So let's see how to do that. There's a tool called Tox that does exactly this. There's a whole bunch of configuration options, but you can start pretty simple, and this is enough for our project right now. So the line I've highlighted says that we want to test under Python 3.6 and Python 3.7. Underneath, it says we need PyTest to run our tests, and then the command, the last line, just says run PyTest, and assuming it completes with a 0 exit code, then it assumes the test's passed. So when you install tox, the first line, and then you run tox, the second line, for each of those Python distributions that you asked it to test against, it will create you a virtual env, assuming you have that version of Python on your machine somewhere. It will create a Python 3.6 virtual env and run your tests, and then it will create a version of a Python 3.7 virtual env and run your tests in there, and it spits out a whole load of output like this, and then at the end, if everything succeeded, it says Python 3.6 was okay, Python 3.7 was okay, and if it was all okay, you get a nice congratulations and a smiley face. So to go back to pretty much the first slide, I'm going to talk about that source directory now. So when you run tox, this is one of the bits of output you get at the start, where this is the path to my project, the folder containing my setup script. And if I had put my source code in there, even though it's running in a virtual env, it's running from my project directory. So if I imported hello world, that directory, the project directory, is in the Python path, so it would import that version of the code. Whereas what we're really trying to test here is that if we create a virtual environment and install our project into it, then that code works. So we would be importing the working version of the code rather than the installed version of the code. By creating a source directory, we just move the file outside of our Python path, which means that this test is more valid than it would be otherwise. So that's why we did that. And also, so actually, there's some documentation online about the current best practice for Python packaging, and it doesn't say to put your code in a source directory, but if you look at pip itself, they have a source directory. So I think if we follow by example rather than reading the documentation, in this case, that's good advice. How are we doing for time? Okay, 12 minutes. I think we're going to be okay. So we've tested it on our own machine, but developers' machines are messy things. We have all installed programs and Python scripts and libraries that we can't even remember. So at any one of those really could be sitting in the background messing up our tests, because it's not a clean environment for running our tests. It's not bad for while you're developing, but it doesn't really say that our code is going to work on somebody else's computer. So what we want to do is run our code on somebody else's computer, and a nice service, especially if you're publishing open source code, is Travis, because it's free for open source projects. By going to Travis and enabling the project, and then creating one of these configuration files, every time you commit to GitHub, which is the only repo, source that they support, if I remember rightly. It will check out your code into a clean virtual machine, and then it will run the tests, and then it will tell you whether that PR succeeds or fails. But the configuration, again, can be quite simple for simple projects. So here we've just said, I want to test under Python 3.6 and 3.7. There's a little bit of duplication with our tox config, but it's not a huge amount. And I've said to install the project, just install tox. Because tox already knows how to install our code, so we can then delegate to tox after this point. And then the script at the bottom is how we actually run our tests. So in this case, we're saying run tox. The V flag means verbose, and then the EPY flag, or it's a parameter, basically says to run using the system Python. So because we're allowing Travis to install Python 3.6 on one machine, 3.7 on another machine, we're just saying don't create a virtual environment, just use that version of Python that's already available. So, I mean, I would say this is kind of where you can stop for small projects, especially something as small as Hello World. There is a bunch of other stuff you can do for extra credit. You can stick badges at the top of your README. It's a really handy way to see whether your project's broken or not, or even just the quality of the project. So we can get code coverage metrics using coveralls or CodeCov.io. We can get quality metrics using Code Climate or Landscape.io. There's a bunch of these projects, by the way. I'm just picking the ones I've used. We can add bump version configuration. Bump version is really neat for just kind of bumping up your major, minor, or patch number and tagging so that GitHub understands it's a release and will automatically publish its own version of your source distribution. Yeah, it's a neat little project. We can test on other platforms other than just Linux, which is what Travis runs under. We can write more documentation. You can always write more documentation. We can have a contributors section. This is a lot of work. I don't know if you've noticed this, and I recommend that you don't do any of this. So all this stuff took me a couple of days just to get the sample code up and running. It's boring, time-consuming, and error-prone. And you know what's really good for solving boring, time-consuming, and error-prone tasks? Computer software. So I heard somebody mutter Cookiecutter, which was good. So Cookiecutter is a tool that generates projects from templates. And there's a bunch of really good templates for all sorts of different types of projects, both Python projects and non-Python projects. So let's just pretend that we didn't spend all that time doing all of this by hand. This is the biggest bait and switch I've ever done in a talk. Yonel, I'm going to attempt his surname for the first time. It has accents in it I've never seen before, so I'm just going to plow on through. Yonel Christian Mariez has written a template for Python projects that closely matches the advice that I've given over the last 56 slides. So whereas this talk has been quite opinionated, Yonel's template has a bunch of options, so it asks you lots of questions. So the way that we run this is first we install Cookiecutter, then we run Cookiecutter, and then here I've given it, this is a path to a GitHub project. So we don't even have to install the template ourselves. Cookiecutter will download the latest version for us and run it. It will ask us lots of questions because it supports PyTest as well as unit test. It supports Travis and other CI solutions, and it just asks you whether you want to use those or which ones you want to use in certain cases. And then we copy in our code and tests, which is the thing we're actually trying to publish. We make some minor file tweaks. Obviously, we still need to write the README. So I should say that when I ran Cookiecutter, it didn't work exactly the way I wanted it to first time. So there were some manual tweaks. But ultimately, getting from the start of this process to the end of this process took 5 minutes, as opposed to 2 days. And I'm up with a project that's pretty much exactly what I wanted. And then we're done. So I could have, and this is now what the project looks like. There's a whole bunch of stuff it's generated for me. And mostly it's pretty similar to what I've described. So I could have cut this talk down to the last 2 slides. This is basically a lightning talk that I managed to spread out to about 35 minutes. But hopefully it gives you a good overview of good packaging practice and why we do the things that we do, and also gives you the ability to tweak it to your particular requirements. Sometimes when you run one of these Cookiecutters and you get hundreds of files that you don't understand, you start to wonder why those practices are in place. Hopefully I've tried to describe some of those. So just to finish off, I'd like to say I have attempted to describe current practice. I've looked at a bunch of different projects, I've read a bunch of documentation, I've tried to find the best practice. It's still difficult sometimes because some of this documentation is more up to date. People disagree on the best practice in certain cases. But we're also in a situation where over the next few years things are probably going to change. So there's a few PEPs that are recommending different ways of doing things in the future. So people haven't been very happy with setup scripts for a while. So the idea of putting configuration in a script doesn't seem like a good idea. It's really configuration. There's already in the latest versions of pip and setup tools the ability to move all that stuff we put in the call to setup. You can put in setup.config, and then you just have an empty call to setup in your setup.py, which could be nicer in certain cases. Because it's in config, you can actually have code to manage that configuration file, which could make life easier in future. As far as I'm aware, that project doesn't exist yet. If anybody wants to create it and publish it to PyPI, that would be awesome. There's also a recommendation to create this PyProject TOML file, which is really a replacement for requirements.txt. It sort of overlaps a bit with Pipfile. It's a replacement for setup.py and setup.config entirely. It sort of overlaps with Pipfile a bit, which is also a standard. So I don't know where things are going. There are some tools that take different approaches to publishing and managing your dependencies. We have Poetry, Flit, and Hatch. I've only had quick looks at those, and I've attempted to kind of summarize where they overlap with other stuff that we've talked about. So Poetry and Hatch, for example, have code templates. It will automatically create you a project from scratch. So it kind of overlaps with Cookiecutter. Poetry overlaps with setup.py, as does Flit, because they both have their own, they both basically put your project metadata inside the PyProject TOML. Yeah, it's complicated. To be honest, I'm quite excited about the way this could end up, but it's difficult to work out which path we're going to take and where we're going to end up. Thank you very much. Oops, I've done the wrong thing again. There we go. So the slides and code are up on GitHub, and I recommend you follow me on Twitter because I'm awesome. Thank you.
There's time for 1 or 2 questions if anyone has a question for Mark.
I'm glad I came to this talk because
thank you.
I've done very much what you've just done in the last 2 weeks. And there's all sorts of things I should have done differently. But one thing I did find was bump version is a little bit stale, and perhaps take a look at bump version 2. It very much does exactly the same thing, but there's a couple of bug fixes in it.
Oh, okay, thank you for that.
Thank you very much, that was great.
Hi. Just one question about versions. So in setup.py we put the version of our project, but then also in the code base it's good to have the version number as a variable on the module somewhere. Either as like .version or _ version or something like that. But what I find myself is that I always forget to update the one in the code. So I publish something and then it's like 2.1.2, but actually my code says 2.0.
I have an answer to this. So a bad practice that people follow sometimes is to actually import their module into the setup.py file. So as part of your installation process, it just sort of extracts it from the running code. Yeah. Or even sometimes they open the file and just like extract it using a regular expression. Really bad idea, because ultimately if our packaging formats change in the future, that file may not be where you've tried to load it from. Bump version solves this problem. So bump version, you give it a list of the files that contain the version number, and if you want to be really specific, you can tell it the pattern that you expect. So in the source code, it will be dunder version equals, and it will go and just kind of, when it works out what the new version is, when you run it, it goes through all of those files and updates them all consistently.
Okay.
Then it creates a tag with the same version that follows the same format as GitHub expects. It's an awesome little tool. Although I hear bump version 2 is better, but I haven't checked that out yet.
Okay, thanks a lot.
No problem. Oh no, Stefan is going to ask a difficult question.
Can you show the slide with Markdown and restructured text?
Sorry, which slide did you have?
The first slide about Markdown. mkdocs and things.
Oh, Markdown. Oh, this was the comparison table. Okay, let me try and find that.
Just for me.
Yeah. Oh wow, it's a wolf. It comes up with a different image every time I connect it to a.
It's your background.
A screen. Come on.
Please.
No. Okay. Was there something you disagreed with, or something you had a question about?
No, in fact, it's not a question, but with the last version of Sphinx, Sphinx 2...
Sphinx does support Markdown now.
Yeah, and there is a library for that with Sphinx 1.8.
Okay.
We can start to use it with Python.
I had forgotten to update my slide with that. I did not know that when I wrote the slide, but I do know that now.
Yeah, we use it for Python because for the code of conduct.
Okay, and that's working well?
Yeah.
Good.
Thank you.
I get the impression there's a lot of change in the Python packaging ecosystem at the moment. Some of the stuff you covered, some of the other stuff around the different tools for managing packages you have installed. Do you see that change accelerating or slowing down? Do you see us settling to a talk at PyCon Ireland 2020 or 2019 or 2021 where it'll be a kind of settled best practice?
So currently Python doesn't have a BDFL. So I think it's difficult to really know how fast anything in Python is going to move in the near future while we're still working out how decisions are made and how we kind of move forwards on this. There's always the chance that something like pipenv might appear that just sort of blows everything else out of the water. Currently that's not really the situation. There's a bunch of really, really good and interesting tools out there though. If you're looking for an alternative, I really like the look of poetry when I was flicking through it, so that's the one I would start with. Okay, I think that's it. Thank you very much.